So let's look at the first question. So you have a coil with a self-inductance of 57 millihenry and it's connected to a battery. So if I like to draw, I'll draw a coil. Then this coil here has a inductance, which is L, self-inductance of 57 millihenry. So I'll write it as 57 times 10 to the negative 3 Henry. Okay, and it's connected to a battery. So what I will do is I will probably break a little of the loop and connect it to a battery. Okay, so now the current is going to take 60 milliseconds to reach the maximum steady value of 0.50 ampere. So when you just connect it to the battery, initially there will be no current before you connect the battery, right? But once you connect the battery into it, the current will rise to the value of 0.50 ampere. This will be like the final value after the current has become stable. Initially, there's no current. Install the battery, the current rise up to the value of 0.50 ampere. So that's the final value. The initial value will be 0. 0 ampere will be the initial value, because before that, you are not connecting the loop to any power source. Okay, so now they ask, what is the back EMF induced? Well, back EMF, right, is just equivalent to induced EMF. But in this case, why do they call it back EMF? Because this back EMF here, it happens when you install a battery into a circuit. So you later see that because of Lenz's law, the induced EMF will try to oppose this change of current, right? So the EMF is in the direction opposite to the direction of the battery that we install here. Okay, the battery will produce an EMF, but the induced EMF is in the opposite direction to the direction of this EMF of the battery. That's why I call it back EMF. Okay, but you can just think of it as induced EMF. Don't need to be too complicated about it. Okay, so we know that the initial current is 0 ampere, and you know that the final current will be 0.50 ampere, and the whole thing here is going to take an amount of time which is 60 milliseconds. Okay, I believe, do we need a diagram? Okay, let's draw a diagram. So the initial situation, the final situation. So your current is going to flow this way. Your final situation, your current will be 0.50 ampere. Initially, you're not even connected to any battery. So initially, your current will be 0. And this process here is going to take up some time to go from initial to final. And the amount of time taken is 60 milliseconds. Okay, that's the relationship between everything here. Okay, so they ask you to find the induced EMF or the back EMF. So back EMF is just induced EMF equals to negative L time rate of change of current. Okay, because now in this situation here, you are not given the rate of change of current. You are given the initial and final. So that means that you cannot immediately determine the back EMF. What you can only determine is the average back EMF. Okay, so you have to change it into average form. Then become negative L, maybe delta I over delta T. Okay, so if you break it open, then it will be I final minus I initial divided by time final divided by minus time initial, but that one is just delta T. You don't need to break it open. So now you can just substitute in everything. Negative 57 times 10 to the power of negative 3. I final is 0.50. I initial is 0. Then the amount of time is 60 milliseconds. Okay, so if you put that into your calculator, you get a value of negative 0.475 volt. Okay, so this is the average back EMF that is created by due to the change of current happening over here. Okay, but because they call it back EMF, right? You can write the back EMF be equals to 0.475 volt. You can remove the negative sign here because the negative sign here is trying to tell you that it will be in the direction that oppose the change in current. So it actually represents the meaning of the back over here. Okay, so the back EMF, you can write the back EMF, then you don't need to write the negative sign because the negative sign is trying to say that it is opposing the direction of the EMF created by this battery over here. So that is represented by the meaning of back already.